Hey guys, Mr. Bicen, and I cannot believe it's this time of year already. We are at the day before Core Pure 1 live stream. I am in complete shock at how fast this year has gone, and I've been seeing a little bit of what's been going in the chat. People talking about, oh, what's the predictions? What do we think's coming up? No one knows until the exam is actually started what is coming up. But we will know a lot more after we've seen the first paper, won't we? So I would love to know how people are feeling. Like, I am imagining I'm going to see the words I'm predicting I'm going to see here. I think I'm going to be seeing stressed, nervous, excited, ready, not ready. I don't know, like a few different things that people are going to be thinking about. God, we've got some self-taught people. Congratulations, Magnus. If you're self-taught, that's really, really impressive stuff that you've got. So well done. And cooked, I've obviously had to get used to like learning all these different things that people say, but like cooked is something I've learned over the years of being a teacher of what this means. So this session is going to be a couple of different things, right? I've picked 5 topics that I wanted to have a look at. Some things that are usual, unusual, nothing super duper scary, nothing that's like really crazy. A little bit here and there is a bit unusual. And I've done that because I just want this to be something that will kind of refresh some of these things like into your mind before the exam. So that you can kind of like look over these things. And to be honest, if you do see something that is very scary looking, what do you think my advice would be to you? What would be my advice if you turn over, say, question 6 and it looks like a complete, like, terrible, terrible question? I want to have a look in the chat to see what do we think I would advise you to do in that situation. So Shane is correct. Use what you know. Skipping the question and coming back to it, reading through it and having a think through that bit. Yep. Doing something, trying getting started with it. Keeping a cool head and just saying like, well, you know what, it's in the specification. It's definitely something that I should be able to do. I'm sure I've done some of these questions that we've got there. And I like think about your happy place. For me, my happy place is doing maths. So if I come across a question that's really difficult, I will be in my happy place anyway. Okay, so what we're going to do is a little bit different to some of the other live streams that I've done. Is I'm going to start off with these different topics, and before we do the topic, we're going to use the chat to kind of like pull up lots of the kind of key pieces of information from this kind of stuff. I've decided to go with some stuff on series, polar coordinates, some stuff on complex numbers, proof by induction with derivatives, because that's something that they kind of sneakily added into the specification. And I was like, you know what? I don't think I've got any videos of proof by induction with derivatives, and that was asked about in 2023, so I thought it might be something useful for us to have a look at. And then we're going to finish it off with something that is exactly like I was just talking about, something where we're going to be doing modeling with vectors, where you turn the page and you go like, oh, this looks absolutely gross, I don't want to do this question. But we're going to try and think about how we kind of like keep ourselves calm in that kind of scenario. Yeah, and just make sure that we get as many marks as we possibly can do that we've got here. Okay, please also, oh, I was showing stuff on my screen and I haven't even started sharing my screen with you. This isn't a good sign, is it? So we've got series, polar coordinates, complex numbers, proof by induction with derivatives, modeling with vectors. And I've said here, please make sure that you've prepared for all the topics, especially differential equations. This is likely to appear in both papers, so be prepared. So today is really just a kind of last minute, getting ourselves in the right mindset, doing some of these questions. But if someone was saying in the chat, like, what's my predictions going to be? I don't do predictions because you can't do predictions before the first paper. After the first paper, different thing altogether. But I always expect to see differential equations when I open a core pure paper because it's likely to be in both of those papers that we've got there. Okay, so we are going to start with series. I'd like to know the kinds of things that we're going to write down on this page that we should know, that we should think about for series kinds of questions. And we're going to see how much we can kind of get on here as a little bit of revision before we then actually start doing one of the questions that I've got. And if you want to follow along with these questions, they are linked in the description that we've got here as well. Okay, so we've got 2 kinds of things. People have started talking to me about the standard summation formulae. So that's definitely something that we're going to want to use for this, the standard summation formulae. And then I've also seen that people are mentioning method of differences. Now, the nice thing about these questions is they will usually tell you which of these 2 things that you should be using, whether this is standard summation or method of differences. They'll often say using method of differences. Of course, there's also Maclaurin stuff, but I'm actually talking more about the kind of sigma types of series and things that we've got here instead, okay? Standard summation, I'm not going to ask you to type this. There's only one of them that's not in the formula book, which is the sum of r, which is a half n plus 1. The other ones are in the formula booklet that we've got. Method of differences, we know that kind of standard thing of writing out all of these parts. Now, are there any sort of hints or tips for this topic? I'm going to say hints or tips. There's a few things that I always think about when I'm doing a series question that might not be that important for this question we're going to look at, but it is useful for other ones. So are there any things? Oh, I like that one that Breezy has just said. Factorize, don't expand. Factorize is better than expanding. That's a really important one that we've got there. Anything else that when you're like looking at a question that you feel like, oh, I need to make sure I do this when I look at a series question, just to be really careful. Something about being very careful with that we've got here. Yeah, with the substitution with numbers into it, what do you sometimes need to think really carefully about with this? Live stream is probably going to be about an hour and a half. Yeah, good. If the number at the bottom is not 1, so you must make sure that you're looking at the bottom part and the top part. That's a really, really important thing that they sometimes sneak you with. And also, Erin said if it's in range, maybe if the number on the bottom was something like, I don't know, from 12 and then the number on the top is 8, obviously that wouldn't make any sense. That's what it means about being in range for this kind of thing. Iman has said check whether it's n or 2n on the top. If it's n, it's straightforward. If it's 2n, you've got to be a bit more careful with this kind of thing. And of course, the standard things, like if we were going to be doing something from say like 10 to 28, we know that this would be the same as doing from 1 to 28 minus from 1 to, what should the number be that goes on the top? Perfect. 9 that we've got for this one, okay? If it was a 2n that was at the top, when you do substituting into the formula, let's say that it was from r equals 1, this is to n. If it was from r equals 1 to 2n, it would be a half of 2n plus 1. So you just need to be really careful of like looking out for all of these kinds of things that we have got here, okay? So we're going to look at this question, and if you do want to find some extra questions, you can always go to FP2 from the International A-Level. This one's taken from June 2017. And a nice friendly 1 marker. This is also quite a friendly question overall. I've done this as a nice little warm-up for us to do in this question that we've got here, okay? So we're going to show that this thing is equal to this thing. I'm definitely going to work on the left-hand side here. So we have r cubed minus r minus 1 cubed. I should use the identity symbol. If you don't do that, you won't get punished for this. I think we can do binomial expansion for a trinomial here. Not a trinomial, for a power of 3, excuse me. So that would be an r cubed minus 3r squared plus 3r minus 1. So it's r cubed minus r cubed plus 3r squared minus 3r plus 1. So the r cubes cancel out, and we do get the thing that they were looking for, which is the 3r squared minus 3r plus 1. A very easy 1 marker for this. But of course, if you couldn't do that 1 marker, you could obviously still come on to the next part of this as well, okay? So it says for part B, hence prove by method of differences. Oh, that's interesting. It's telling us to use method of differences in this question to prove that the sum of r squared is this thing. But it does then also tell us that you may use this thing without proof, which is an example of the standard summation formulae. So this is a question I selected because typically it's either one or the other. It's method of differences or standard summation. And this one's already telling me that I need to do a mixture of different things for this. So someone's already suggested this. I think we've got someone suggested to do the method of differences on the part A that we've got there. Because if I do the method of differences on this part, I will actually be finding out the sum of this. So I could actually start that by saying the sum of r cubed minus r minus 1 cubed from r equals 1 to n. That's going to be equivalent to doing the sum of 3r squared minus 3r plus 1 from r equals 1 to n. So that's going to be easier to find out with method of differences, and then I can do some standard summation stuff with this part that's over here. So for the method of differences, I hate the amount of times you need to write r equals 1 and n and all of that stuff, but we will try and do it properly. So I'll start off, I'll do r equals 1, r equals 2, I might do a few more, r equals n minus 1, and r equals n. So when it's 1, I'll be subbing it in here. That'd be my 1 cubed minus 0 cubed. I'll have 2 cubed minus 1 cubed. You can already see which are the ones that are going to cancel. And then here, I mean, you could do an r equals 3 if you wanted to, but it's not required. So this would be an n minus 1 cubed minus an n minus 2 cubed. And then for this part, you're going to have your n cubed minus n minus 1 cubed. So the pattern of the things that are cancelling, you get this one and then diagonal downwards. So this one would cancel with one diagonally downwards, and this one cancels with this one diagonally downwards, which actually shows that weirdly this whole thing is just equal to n cubed that we've got for this part. So now I know that n cubed is the left-hand side of this. So n cubed is the sum of this part that we've got written over here. So that's the sum from r equals 1 to n of 3r squared minus 3r plus 1. And I'm trying to remember what we're actually trying to do in this question. We're actually trying to find out the sum of r squared. So we are going to try and isolate this r squared part that we've got right here. That's the thing that I'm going to try and make the subject of this. So let me add in an extra page. So we now have that this is n cubed. This will be 3r squareds minus 3, the sum of r, and then with the sum of 1, like this. So n cubed is 3, the sum of r squared. Can't use the formula for that because that's the thing that I'm trying to prove for this part. And then the sum of r is a half n plus 1. So it's going to be 3 times a half n plus 1. And then that part there is n that we've got. Remember, this is the thing we are trying to find by itself. So I'm going to try and now just make that the subject. So it will be that 3, the sum of r squared, is n cubed minus 3 over 2n, n plus 1, plus n. And we did say something earlier. We said that factorizing is way better. So I'm going to start off by saying that these things on the right-hand side have all got a common factor. Getting so bored of writing this r equals 1 and n stuff, but we've got to do it. So it's going to be an n squared. That will be left with a minus 3 over 2n, sorry, 3 over 2n plus 1, and a plus 1. You can see where this question is going. It's hopefully going to give us the thing that we are used to seeing. Just going to keep working on this part, actually. So it's going to be an n squared minus 3 over 2n minus a half. Have I got any of these things? Should that have been... Yeah, when I moved this around, that should have been a plus. And that should have been a minus. So me switching the sides around, I think, has made some confusion, because that should be a plus and a plus. I bet I'm going to look at the chat and it's going to be saying that like all over the place, that I've got this wrong. Yeah, I've got that bit wrong, but I've done the signs. I spotted it because I knew it wasn't going to give me the thing I was looking for. I think it was here when I was juggling everything around. It should have been an n cubed plus the 3 over 2n, n plus 1 over here. And that part should have been the minus n. So good to see this, to see how you can spot these mistakes as we go. So I'm also going to take the half out because it looks like there's this half part that we've got. So it's going to be an n over 2, 2n squared plus 3n plus 1. It's n over 2, 2n plus 1, n plus 1, which factorizes. And so we now get the familiar formula that we're looking for, that the sum of r squared is n over 6, n plus 1, 2n plus 1. Is that exactly how they have it written? No, I'm going to do it with the long fractional time that they've got written there, n plus 1 over 6. Because, I don't know if you've seen that video I've done recently, that is making sure it looks exactly like the thing that they want it to be, like this, okay? So, doesn't seem too crazy, but it was just a little warm-up question that we've got here. Now, I should actually say, because I was going to say, if the exams this year, they're like really close to each other, right? We've got like the Tuesday exam, and then we've got the Thursday exam. So my day tomorrow, obviously your day is going to be way more stressful than my day, but my day tomorrow is going to be very busy because I want to do a reaction video to the exam to tell you what I thought of it as soon as I can get a hold of like how the questions were and what it looked like. I'll also do a poll on the channel as well, so that when you come out of the exam, if you want to see what other people across the country have thought, you can vote to say like how you thought the exam was out of 5. And then on Tuesday night, I am going to stay up late preparing a session that if you want to come to on Wednesday morning, it's at 11 a.m. till about 2 p.m, that kind of morning session, where I'm going to be going over all the topics that haven't come up in paper 1 that I think could be coming up in paper 2. Last year this sold out, so if you are interested in coming to this, it's already got a lot of tickets that have sold for it already. If you go into the description, you can buy, it's only £15 for like 3 hours plus extra questions and an extra video to go through. If you are at school at that time, you can just purchase the version that says recording only. And if you buy that version that says recording only, you just get the materials sent to you at about 3 o'clock. So when you come home from school, it'll be like perfect revision of like targeted stuff on the next topics. Obviously, I don't have the exact questions that will be in it, but we know that if something like matrices hasn't come up, I'll do a little bit of some stuff on matrices. And there's already a lot of you that I'm going to be seeing there. So if you do want to go to that, it's in the description. But it's only £15 for that. So it might be something that you guys would be interested in. Mark scheme for this is kind of pointless because the whole thing was a bit of a show that you've got. Yeah, if someone, by the way, if you bought the live session but you just want the recording, the live session, you still get sent the recording afterwards as well. So everyone who buys it, the only reason I've done the option of the recording is in case you're at school and it frees up a space for someone to come to the live session instead. So if you have any questions on that, I'll see if I can answer any of those things later on as well. So polar coordinates that we've got here. I want you to tell me some of the things that we just need to know, memorize, have in our head about polar coordinates. And I'm going to do my best of trying to write down the things that I can see from the chat. So don't rush this. I'd much rather quality answers than things just coming in here straight away. Yeah, if you bought the session, you'll get a link before it starts. I'll send you a link like that time to tell you like where you can buy this. But last time it did sell out for further. For maths, it sold out during the live stream. So like if you're interested in it, definitely worth something coming to. Plus, it's going to be fun to do that kind of session all together, revising some of those key topics. Be good focus. Okay, so we've got some of these key things here. Someone has told me that x is equal to r cos theta and that y is equal to r sine theta. Obviously going to be very useful that we've got here. Awan has talked about we need to know how to integrate things like sine squared x and cos squared x. I'll be coming back to that in a second and talking about what those conversions are in just a moment. We've got the rearranged double angle formula there. Oh yeah, people have talked about this part, that x squared plus y squared is equal to r squared. We do have from piece control D that dx d theta is 0 for when it's perpendicular, and that dy d theta is equal to when it's parallel. This is obviously to the initial line. Perp to initial line. I wonder if there's anything else that we've got here that we're not missing. Integrating tan squared x. Yeah, I guess tan squared x, you'd have to use an identity on tan squared x for that part. Yeah, good. Ali, the integration is like rays of sunshine from the initial line moving anti-clockwise, so that if we had like some kind of curve like this, when we're actually doing integration, the limits are like this kind of thing. So it would be from 0 to alpha. It kind of does it like kind of like hands around a clock or something like that. Of course, we would be using radians when we do this question. We've talked about dimples and eggs and people saying like, oh, do I need to have these things memorized? Do I need that kind of stuff memorized? I don't know if it's something that I would memorize for dimples and eggs. I think it's something they would usually talk you through in the question, where if you had something like that, we're talking about there needs to be 1, 2, 3 tangents where dx d theta is equal to 0. I don't think that's something that they would just say, prove it. I think it's something that would be in the context of a kind of question like that as well. Yeah, the rays of sunshine analogy is cute. I like that. I'm pleased that people like that as well. So there's actually something that we talked about recently from the new specification. They talked about how r is only going to be greater than 0 for edXL. And actually that does get mentioned in this question. Okay, so this is, as someone said, do we have to draw petals or polar roses and those kinds of things? This is a great example where they've actually restricted the domain for theta. And by restricting that domain for theta, you're not going to get these extra parts that would usually be on the diagram. We're just kind of restricting it to these bits that we've got. So I picked this one actually from the same paper as the previous part because I just thought it covered so many different things about polar equations. And I haven't forgotten this. I will be coming back to this part in just a second, okay? So this question says we've got a sketch of the curve with polar equation 4 cos 2 theta between minus pi over 4 and pi over 4. So this part must be that because this is pi over 4, 45 degrees, and this is minus 45 degrees. And then 3 pi over 4 and 5 pi over 4. So it's kind of like measuring it all around there. Weird that they've got it with negative and positive and then both of them positives, why they didn't do that one negative, but whatever. And r is 4 cos 2 theta. And then we've got a whole lot of text to read here that the lines PQ, QR, RS, and SP are tangents to the curve where QR and SP are parallel to the initial line and PQ and RS are perpendicular to the initial line. We're going to find the polar coordinates, which means you need to find r and theta of the points where the tangent SP touches the curve. So I want to say for SP, I want to find those two coordinates that we've got here. And we've been told we're going to give the values of theta to 3 significant figures. So if we're talking about it being parallel to the initial line, aren't we? Yeah, we're talking about SP, which is where it's parallel to the initial line. That's going to be that dy by d theta is equal to 0 for this first part of the question. So dy by d theta is going to be equal to 0. And we're going to use the additional fact that we said at the beginning, that y is r sine theta. So y is r sine theta. And I'm also going to I personally just like having the extra equation just like written right at the top of my page, so I have it to refer to. So there's my 4 cos 2 theta. So y, if I substitute r, which is right here, in place for r, I get 4 cos 2 theta sine theta. Now I'm going to differentiate this. However, I have a preference. What do you think my preference is going to be before I start differentiating? You know, half the time I ask you questions is so that I can drink my water because I get so thirsty when I'm teaching. I personally want it all in terms of theta. I don't know why. You can do it without. I just think it's easier to break the 2 theta down now, because otherwise you're going to get a product rule and there's like 2 thetas like all over the place. So my preference is to break it down, and my preference just felt like I wanted to go with the 1 minus 2 sine squared theta, because then everything is all to do with sine theta. Weirdly, it just kind of felt more comfortable for me to have that. So we get y is equal to 4 sine theta minus 8 sine squared theta. So finally I can now differentiate it with dy by d theta. Sine goes to cos, and then I will pull the power down and reduce the power by 1. And I will also multiply by, hang on a second, I can't even expand brackets properly, can I? That shouldn't be a squared, that should be a cubed. So let's try this one more time. 8 with the power pulled down is going to be 24. I'll reduce the power by 1, and I need to multiply by the derivative of sine theta, which is cos theta, that is like this, okay? And we now need to say that dy by d theta is equal to 0. So what's going to be the best thing to do here to try and find out what theta is equal to? What do you think is going to be the best thing to do to that trig equation? I think there's something that should feel quite straightforward that we've got. I'm going to get rid of the cos. I'm actually not going to replace the sine squared with stuff. I'm actually just going to get rid of the coses. You can either factor it out, you can cancel it. Remember, if you cancel it, it is a solution. So I'm just going to jot down that cos theta is equal to 0, which means that theta is equal to pi over 2. However, that's clearly not one of the things that is being included. Pi over 2 is talking about some part over here, which is actually, because it's a different part of the petal, it's talking about the top part. But we're not doing that, because it's not included in the domain that we've got there. So I can just reject that, and then I can continue with the fact that we have 4 minus 24 sine squared theta is equal to 0. So 4 over 24 is sine squared theta. Let's add in an extra page. So that's sine squared theta is a sixth. So sine theta is the square root of 1 over the square root of 6, or 1 over root 6, like this. There could be a negative, but we're going to just look at the diagram and figure out which are the ones that we're looking for, okay? So let's do 1 divided by, am I in degrees mode here? I don't want to be in degrees mode, do I? I need to be in radians because it's a calculus topic. So I will do 1 divided by the square root of 6, and I'll do the inverse sign of that. And we get the answer 0.421 to 3 significant figures. Now, that is referring to, on the diagram, that's definitely referring to this one, 0.421 for that angle that we've got there. Now, you could just use symmetry for this as well, or you could just go about solving the equation. If I do pi minus the answer, I will get the other solution. If I do pi minus the answer, I get that theta is 2.72 to 3 decimal places. Now, I did say when you took the square root, it could have been plus or minus. This is a side note. This isn't something that we actually need to do. If sine theta was minus 1 over root 6, I'm going to talk to you about the other values that we get. So I'll do minus 1 over root 6, and I'll do the inverse sign of that answer. And you get minus 0.421. And if I do pi minus the answer for the other solution, you get 3.56 instead. So those are referring to things. They're referring to some other solutions that we've got here, because negative 0.421 is referring to this one, but that's not for the line PS. That's for the line RQ. And 3.56, well, that's more than pi. Pi would be here. So it's actually referring to this part here. That's that line going all the way around is when it comes from the negative solutions that we've got. So we only needed the two that were on the top half, which was 2.72 and 0.421. Now we are going to find the value of r. R is 4 cos 2 theta. So you could just type this all into the calculator and it probably would work out, but I'm going to do the exact maths of how we're looking with this kind of stuff, okay? So r is going to be 4 lots of 1 minus 2 sine squared theta. In fact, I think we worked that out earlier on. Didn't we say that that was here? We just subbed it in straight away. So let's go. R is 4 lots of 1 minus 2 sine squared theta. And we know what sine squared theta is equal to. Sine squared theta is 1/6. So this is 4, 1 minus 2 times by 1/6. So that's 1 minus 2 over 6, times it by 4. And so r is 8/3. Hence, the polar coordinates are r theta and r theta. Okay, let's keep going. Now it's going to say find the exact area of the finite region bounded by the curve C shown unshaded in figure 1. Now there's a question like this in 2019. It was like a really similar kind of thing where there was like a rectangle on the outside and a little shape in the middle that we've got. So we're basically going to try and find out the area of this whole like blue section that we've got here. Now we did talk about these kind of like rays of sunlight that we've got. They've interestingly told us that theta goes up to pi over 4, which means that if I wanted to find out this section, which I'll do in this purple color, that would be, what would my limits be if I was just going to try and find that one little section that we've got there? I actually think someone's already answered that in the, I think Part's already said this. I'm going to do it between 0 and pi over 4. Yeah, some people are really, really fast in the chat. There's a lot of stuff going on in the chat, so it's quite hard for me to keep up with all of it. But when I see a good answer like that, it's nice to see. So we are going to be saying it's normally, we didn't even mention this, did we? I think someone did, and I didn't think I wrote it down, that to find the area, you do half the integral of r squared d theta. Okay, that's how we find the area. So we're going to be doing a half the integral of r squared d theta between 0 and pi over 4, but that is only the purple section, and I don't want just the purple section, I want all of them, and there are obviously 4 of those. It's fully symmetrical, so it's going to be that multiplied by 4. So this is 2 the integral of r squared. R squared is going to be 16 cos squared 2 theta. 16 cos squared 2 theta d theta from 0 to pi over 4. I'll take that 16 to the front, so I have 32 the integral of cos squared 2 theta d theta from 0 to pi over 4. And now I'm going to jump back to the thing I said I was going to come back to, which is these things we remind us of how we integrate. Now I'm not going to ask you to type this because I think it's a bit too hard to type. However, sine squared is the same as integrating a half minus a half cos 2x dx. That's what we mean by the kind of rearranged double angle formula that we've got. And then the one that we're going to be using in our question for cos is the same thing but with the plus. A half plus a half cos 2x dx that we've got. And the most important thing that is so easy to forget is that the angle doubles. The angle doubles. It's coming from the double angle formula, so it kind of makes sense for this sort of stuff that we've got for this question. So cos squared 2 theta, that is going to be doing a half plus a half cos 4 theta d theta between 0 and pi over 4. Now I can actually do the integration, so it'll be a half theta, sine goes to cos, so it's going to be a sine 4 theta. I need a water. So what's going to be my coefficient that goes out the front of this one? What's the coefficient? Yeah, good. It's going to be an 8. Remember, you can always check this as well. The 8th, when you times it by the 4 here, will give you the half. And we're going with 0 and pi over 4. So when you sub in the pi over 4, half of pi over 4 is pi over 8. Then it's going to be a 0 when you substitute in here, because you've got pi over 4 times 4 is pi, sine of pi is 0. And then when we subtract, I'm going to be subtracting a 0 and a 0 that we've got here. So the final answer is 32 pi over 8, or just 4 pi for this part that we've got here, okay? That was part B. Didn't seem too crazy. You can kind of guess what part C is going to be without even reading the question. It then says, find the area enclosed by the rectangle but outside the curve shown shaded in figure 1. So now we're looking at just this grey part. So basically, find the area of the rectangle and then subtract that white part, which is 4 pi. So I think we've already got like the idea of what the strategy is going to be for this question. We need to find the area of the rectangle, and then we're going to subtract 4 pi. So for the rectangle, there's the initial line that was like this. I think we knew something about this point up here, didn't we? We knew that that was 8 over 3, and that angle was theta, where sine squared theta was 1 over 6, or sine theta was 1 over root 6, like that. And we need to find out how long this rectangle is. Any suggestions of how I can find out how long the rectangle is by having a look at this original diagram that we've got here? What could I do to find out the length of that rectangle as it comes across? Yeah, I want to find r, but what do I do to find out what r is? It's going to be 2r, but what? When what is true? Don't need to do any dx d thetas or anything. It's clearly happening when theta is equal to 0. Well done, Amelia. So at this point here, clearly from the origin, it's 0 over here. So we don't need to do the dx d theta stuff. I just know that it's going to be when theta is equal to 0. So I'm going to just substitute theta is equal to 0 in this. Oh, cos of 0 is 4. So that means this part over here is 4. So I now know that the bottom part of the rectangle is 2 times 4, which is 8. Now for this bit, I can find out what this section is. This is going to be my r sine theta. So if I was going to work out what r sine theta is from over there, we know that the r is 8/3 and the sine theta is 1 over root 6, because we had that from earlier on at this point. So the total height of this, which I shall do in this green colour, this sort of width of it is going to be 2 times 8 over 3 root 6, so that we can now say the area of the rectangle is 8 multiplied by 2 times 8 over 3 root 6. 8 times 2 times 8 divided by 3 divided by the square root of 6 is 64 root 6 over 9. So the shaded area is that rectangular area, 64 root 6 over 9, minus the shaded area that was in the middle, that was 4 pi that we've got for that one. 64 square root of 6 over 9 minus 4 pi. When I've got the same answer as path, I know I've done it right, because I've got the same answers and stuff. I'll do some questions at the end when people are saying like any tips for exam days and stuff. We'll take a little break and kind of talk through some of those questions as well. So these were the mark schemes. We've got those 2 parts for the angles. We did get the 4 pi here, and it is the 64 root 6 over 9 minus 4 pi. They've got it in its like unrationalized form like this one. Now, I'm not going to do too much of a like let's write stuff down for complex numbers here, because there's so much stuff that you need to know for complex numbers, and it's a really broad topic. But we can at least do some of the subtopics, I guess. So we can do some of the subtopics. So I'll start it off that, of course, we could have some things to do with de Moivre's theorem. Is there anything else that's like another kind of topic that we've got here? Roots of unity. What else could come up in complex numbers? It's a huge, huge topic. Yeah, like the loci and regions. Great. Loci and regions on Argand diagrams. Yeah, the different forms of complex numbers. So we've got exponential form. We've got the polygons and stuff with roots of unity. The series. Sums of series where there's like a tricky kind of part that goes with it. The geometry problems. There is so much stuff that we've got in complex numbers. So, you know, even if complex numbers comes up on Tuesday tomorrow, it still could be coming up in Thursday session. So when I'm doing that in between session that I'm going to be planning tomorrow night, and I'm going to be doing that on Wednesday at 11 a.m. When I'm doing that session, I'll look at the questions that have come up so that I can make sure that the things we look at in that session are going to be, just really like well-targeted revision. So if you're interested in that session that I was just saying, £15, bargain to come to. It'll be really fun. It'll be kind of like this, apart from there won't be like a little delay, so I can actually see things in the chat way better when we do those sessions. So if you do want to see how I do with that, you can come along to that session. 15 quid for your revision. Nice way of focusing on that, and I'll probably mention it a couple more times just so everybody knows what I'm doing with this. Okay, nice easy part to begin with. Anything that you think that looks sort of interesting about the left-hand side that makes you like, I wonder if that looks like something that I can do. Is there anything about that left-hand side that makes you think, Yeah, there's definitely like cos and sine stuff. I'm going to do it without a lot of expansion because I think there's a quick way of doing it without a lot of expansion. What about if I just showed you, ignore the cubed bits. What about if I showed you that times that, ignoring the cube? Oh, here we go. Hardy's already got it. Hardy and Harry and Magnus have said about the difference of two squares. I'm sorry if someone had said that earlier on, but I didn't notice it. But this is going to be a difference of two squares for this beginning part. So we have the z plus 1 over z cubed multiplied by the z minus 1 over z cubed. Well, that's the same thing as multiplying them and then cubing the answer like this. So I'm going to do the difference of two squares on this, which just is going to be z squared minus 1 over z squared all cubed. And so now we can just do binomial expansion on this we know that the coefficients are going to be 1, 3, 3, and 1. So it would be z to the power of 6, and then it will be a minus 3. There'll be two of these, which would be z to the power of 4. I'll tell you what, I'll do it like that, z to the power of 4, and then 1 over z squared. It's going to be a plus for the next one, because this part's getting squared. There'll be a z squared, and a 1 over z to the 4. And then the last part's going to be a minus, is going to be 1 over z to the power of 6. Can save a lot of time by doing that difference of two squares. So it's z to the 6 minus 1 over z to the 6. And then we have minus 3z squared plus 3 over z squared. So z to the 6 minus 1 over z to the 6. And I think they want to have it in this form, so I'm going to take out a negative 3 here. So if I take out a negative 3, I get a z squared minus 1 over z squared like this. So k is equal to 3 for this part of this question. If you didn't see it in the exam, I don't think they would want like brute force for like just a 3 mark. So like try and like keep your cool and think, I wonder how I could do this in a different way. Okay, then these parts are pretty straightforward. Given that z is equal to this thing where theta is real, let's show that these things are true. So, I don't know how much detail they want to show for this, so I might have to check the mark scheme afterwards, but if z is cos theta plus I sine theta, I'm going to need to know what z to the n is, so that's cos n theta plus I sine n theta, and I'm going to need to know what z to the minus 1 is. That is cos n theta minus I sine n theta. Now that I've got those things written together, it should make doing this part and this part a lot quicker. So z to the n plus 1 over z to the n is z to the n plus z to the minus n. So that's cos n theta plus I sine n theta plus cos n theta minus I sine n theta. So these cancel, and we get the 2 cos n theta. Pretty straightforward there. And then this one, very similar process, apart from there's going to be the minus. So we have z to the n minus z to the minus n. I am going to write it all out just because it's a kind of show that question. I want to make sure that I'm writing it really simply, really clearly, I mean. And that would become a plus I sine n theta. So those cancel, and we do have the 2I sine n theta for this bit that we've got, okay? I'm going to answer some of those questions, but I've talked about like keeping your cool. I would love to answer some of those questions about staying calm and collected, because obviously I went through this experience last year of doing the exams, so I'd like to be able to kind of share sort of some of my thoughts on some of those things as well. And then here's the part where like a question really does have like, it kind of has like a flow to the question. It's like a bit of a story that's being told here. So it then says, okay, we've done all of this, we've now done this stuff, and now we're going to try and show this stuff that we've got here. And you kind of mentioned that already at the beginning. There's like a sort of mirror image, not exactly the same. There's like something that's going on between these things, and I can clearly use these parts as well. So I think if I was to rearrange this, I now know that z plus 1 over z is 2 cos theta. So if I was going to make cos theta the subject, that's a half z plus 1 over z is cos theta. And then that might help me get this part, which then might help me get to this part as well. And everything should all kind of connect together for this kind of stuff. So if I was going to rearrange this one, it would be z minus 1 over z is 2i sine theta. So it's going to be 1 over 2i, z minus 1 over z is sine theta. So now I have established that this is what cos theta is, and this is what sine theta is. I think I can use that to then kind of combine it, and it hopefully will look like something that we've worked on in part A of the question. So when we're doing cos cubed theta, sine cubed theta, it is 1/2 of z plus 1 over z all cubed multiplied by 1 over 2i z minus 1 over z all cubed. Okay, the cubed will go with the half and give me the eighth. The cubed with this 1 over 2i, well, the 1 over 2 is going to go to the eighth. The I times the I times the I will give minus I. So it's going to be multiplied by 1 over minus 8i. And then we have the the z plus 1 over z cubed and the z minus 1 over z cubed. And now the whole purpose of part 1 of the question has now become clear, because I've got the exact thing in this place. So now I can rewrite it with all of this stuff that's on the right hand side in just a second. So what is that? It's z to the 6 minus 1 over z to the 6. So this is 1 over minus 64i. That is the same as z to the 6 plus 1 over z to the 6. Was it a plus or was it a minus? It was a minus. And then minus 3 minus 3 lots of z squared minus 1 over z squared, like this. Close off those big brackets again, okay? So I'll leave this 64i for a second. Now this thing using the previous part of the question, we know that that is 2i sine n theta. So if it's with the power of 6, it's going to be a 6 theta. So it is a 2i sine 6 theta minus 3 times by 2i sine 2 theta for this question, because this one's got the 2 with it. Now I'm relieved that there are I in both of these places, because the I is going to cancel out with the I in the denominator. So it's minus 1 over 64i, 2i sine 6 theta minus 6i sine 2 theta. Let's actually cancel that now, so it's fully gone. And I think that's what they wanted, apart from they wanted it with a 1 over 32, not a negative 1 over 32. So I'll take out the factor of 2 and I will negate it as well. So when I negate it, these two things are going to swap places, right? So it's going to be a 6 sine 2 theta, a minus 2 sine 6 theta, and that's with the 1 over 64. If I take out a factor of 2, I would get the 1 over 32, 3 sine 2 theta, minus sine 6 theta for this question. Hard stuff, okay? And then the easy part of this question, this is a good part of exam technique. You could still get, if you couldn't do any of this question, you could still do part D of the question. It's just integration, and it's literally just saying, instead of integrating this thing, can you integrate that thing instead? It's exactly the same thing. The limits are between 0 and pi over 8. So I'm not going to integrate the yellow. I'm going to integrate this thing that I'm just pointing my laser at right here, okay? So for part D of the question, between 0 and pi over 8, I'm going to be integrating 1 over 32. I'll put that to the front. 3 sine 2 theta minus sine 6 theta with respect to theta. So cos differentiates to minus sine, so it's going to be a cos 2 theta minus 3 over 2. And then a cos 6 theta minus a sixth. Cos goes to minus sign. Oh, I think it's going to have to be a plus there, isn't it? Have I integrated that right? Please someone tell me I've integrated that right. That's going to be an important thing for me to know if I've integrated it correct. I think I have. I think I have actually. And then 0 and pi over 8. So 1 over 32. When I sub in pi over 8 times 2 is pi over 4. This is where it's important to know these things. Pi over 4 is the same as the square root of 2 over 2. And then we have this part will be a sixth of cos of 6 pi over 8. So 6 pi over 8, the cos of that is minus root 2 over 2. So this is multiplied by minus root 2 over 2. And then when I substitute in 0, well, cos of 0 and cos of 0 is just 1. So it'll be a minus 3 over 2 and a sixth. Definitely need another page. You probably don't need to see me finishing this off, but we're going to do it anyway. So we have here, that is minus 3/4 root 2 minus 1/12 root 2 plus 3 over 2 minus 1/6. So 3/4 and a 12th is 5/6. So this is minus 5/6 root 2, and then 3 over 2 minus a sixth is 4/3. I probably could just leave it like this, or you could multiply it all through. If I multiply it all through, 4/3 times 1 over 32 is 1 over 24. And if I do 5/6 divided by 32, we get minus 5 over 192 root 2. So you could literally have just done this. You could have just done this question, even if you couldn't do the previous parts. Yep, we did have that part. And the other parts will show that for these kinds of questions as well. So I want to take a little bit of a break for a second and just see like how are people feeling about stuff ready for tomorrow. Is this making you feel more stressed? Is this making you feel less stressed? Because I don't know, the whole point of this is for this to be making people feel like, look, we're all in this together. We've all kind of, yeah, we're all in this together. I hope it just makes you see like, these are just like little bits here, just make you feel a little bit more. I mean, maths isn't always relaxing. I think it's relaxing. It's not always relaxing. Making silly mistakes is so easy. Someone said like, how do you like calm down in the exam? I think this is probably a good chance for me to kind of like talk about this as well. Like when I got panicked in the exam, I kind of said to myself like, why am I panicking? Like I had a conversation with myself being like, yeah, I guess this is important, but like, why am I panicking? It's not going to make me do any better. And like look around the room and you'll see most of the time, hopefully it's not a friend of yours, but you'll see other people that are like really stressed. Like, yeah, these are important, but these aren't like the biggest deal in the world. Like when you get to like 5 years time, you'll have forgotten about your A-levels. You'll be working on other things. You'll have a job. You'll be in a different kind of position. So just try and remember my voice, just saying like, it's not a big deal. Like, yeah, do your best. But if you panic on this question, it's not worth panicking. Just try the next question and see how it goes. How can you not panic when you're going wrong? I mean, the more that you panic, the more that you're going to go wrong. So you just have to kind of breathe and say to yourself, you know what? I'll come back to this question when I'm feeling a bit calmer. I think that's probably what we should do. I'm not doing the exams this year, so I can't impact the exams at all. If anything, maybe I'll impact the grade boundaries by people. I'll impact the grade boundaries by hopefully having taught so many people well. That's the real reason the grade boundaries are going up. So we're going to look at this proof by induction derivatives question. Okay, we've got, I think, the proof by induction derivatives. What other ones did I say we were going to do? And then we've got a modelling with vectors question afterwards. So I'm going to just jump back down to this one. Maybe we'll have a little chat after this proof by induction derivatives. Now, I don't know if they would be including this. They did this 2 years ago in 2023. It's the kind of thing that they could throw in most typically for proof by induction. I would imagine something on series. I would imagine something on matrices. Those tend to be the more kind of straightforward ones. The divisibility, I think, is the trickier kind of ones. If you've come to my like aiming for A star sessions, you might have kind of seen that before, and I kind of show you lots of different ways with these kinds of things. So let's try this. Looks absolutely horrible, but this is what I mean by keep your cool. Sometimes maths looks messy, but it's actually not that bad to deal with. So we've got, thankfully, it's very easy function because of sin x. Sin x goes to cos x goes to sin x. Nice and straightforward. If it was sin x, we get all the minuses and stuff happening all over the place, but we can keep this nice and simple here. So it says, prove by induction that for n as the natural numbers, the nth derivative of y is this really ugly looking thing that we've got over here. So we know what we do in these proof by induction questions. We just start off with proving it's true for for 1, assuming that it's true for k, proving that it's true for n equals k plus 1, and then writing a conclusion statement that we've got for this one, okay? So I'm going to start off with, I'm going to do first of all, I'll differentiate y equals e to the 2x sine x. And obviously I need to differentiate this using the product rule. So I will differentiate the e part, keep that the same. Then I will keep the e part and differentiate the sine part to get the cos x. And then the formula with n equals 1 gives us that dy by dx is e to the 2x, 3 to the 1 plus 1 over 2 sine x, plus 3 to the 1 minus 1 over 2 cos x, which I believe is what we've got, because we then have e to the 2x, 4 plus 1 over 2 is 2, so that's 2 sine x, and then 3 minus 1 over 2 is 1, so we get cos x, which is 2e to the 2x sine x, plus e to the 2x cos x, hence true for n equals 1. These questions are a lot of writing. Let's assume that it's true for n equals k. In other words, the kth derivative of y is e to the 2x, and then this is the part I want to write down, 3 to the k plus 1 over 2, 3 to the k plus 1 over 2 sine x, plus 3 to the k minus 1 over 2 cos x. What do I normally do when I do like a proof question? What do I often do in a proof by induction question that gives me something that kind of makes it a bit easier when you're in the exam for this next step when we're going to try and show that it's true for n equals k plus 1? What do I often try and do with that? Yeah, good. Colifin boy. Yeah, write your goal. Go for the thing we're aiming for. What are we aiming for that we've got here? So yes, you could write the entire thing, but these are the parts I'm going to try and say, what's this going to look like? Everything else is kind of obvious. It will be a 3 to the k plus 1 over 2. And this other part is going to be the 3 to the k plus 1 minus 1 over 2. Now, if I was going to manipulate this a bit further, that's going to be a 3 times 3 to the k plus 1 over 2. And this one is the same as 3 times 3 to the power of k minus 1 over 2. So it's actually not that crazy, the thing that we're aiming for. It should be pretty straightforward. So I'm going to differentiate this. So the k is going to become a k plus 1, because obviously to go to the next thing you want to differentiate it. And that k is going to become a k plus 1. So this looks horrible, but I'm just going to do a massive bit of product rule on this. So I'll differentiate this and keep this the same. I'll differentiate this and keep that the same. And then I will keep the first bit the same, and I will differentiate this bit that we've got here. So remember, k is just a constant. So the only thing that's going to happen is sine is going to become cos, and cos is going to become sine. So that's 3 to the k plus 1 over 2 cos x, plus 3 to the k minus 1 over 2 sine x. Now, I probably, with my experience levels, I probably would dive straight into this next part of factoring out the e to the 2x and thinking about the bits that go with sine x. So this is going to be the stuff that goes with sine x. So there's going to be that times that, which is a 3 to the k plus 1, plus a 3k minus 1 over 2. That whole thing is being multiplied by sine x. I probably wouldn't necessarily recommend for everybody to do this, but I don't want to waste too much of your time while we're on this live stream. And so for the other part, the cos part, there's the 2 times this, and there's this part. So for the cos part, there is the 3 to the power of k minus 1, and then we have the other yellow part, which is the 3 to the k plus 1 over 2, and that's all being multiplied by cos x like this. So what do you think I should do with this section and this section? Gives me a chance to have a sip of my water. What do you think I'm going to do with those bits in green? Very good, Yassine, and very good to DRKA as well. Just combine these things together. Yeah, I often get called Mr. Biden. I think like it autocorrects from Bicen to Biden. Apparently, there's someone more important than me with the surname Biden, um, which he is definitely. Objectively, he's a lot more important than me. So we're going to do them as a common denominator here, which means this all needs to get doubled. So it's going to be a 2 times 3 to the k plus 2 plus 3 to the k minus 1 all over 2. Same over here, it's going to be a 2 times 3 to the k minus 2 plus 3 to the k plus 1 all over 2, cosh x. And then we have e to the 2x. Here's the part that maybe some people find hard to spot. We've got that and that, which is 3 times 3 to the k plus 1 over 2. And again, you can spot it in this part. There's 2 of them plus another one, which is 3 of them. That's 3 times 3 to the power of k minus 1 over 2, cosh x. So the final line, because that's what we were aiming for, do you remember? I said it might look like this, or it might look like this. It's exactly what it's looking like. So this is 3 to the power of k plus 1 over 2, plus 3 to the power of k plus 1 minus 1 over 2, cosh x. Hence, true for n equals k plus 1. Now, I wouldn't normally do this, but considering we're doing a live stream and the exam is tomorrow, I'm going to write down everything that I would write down in the exam. So, as it was true, and you could do it as messy as this, because you're just trying to get the mark, as it was true for n equals 1, and when assumed true for n equals k, it was true for n equals k plus 1. Look how messy I am. Still fine. Hence, it is true for all n of the natural numbers. That's definitely going to be fine for that conclusion mark that we've got there. 1 mark for the conclusion. It's basically you get the conclusion like as the mark if you've done the conclusion correctly for this. So the bits that are underlined, if you see them in a mark scheme, that's the stuff that's like essential that has to be there as well. How do you write the statement in math notation? It doesn't even have to say that. I mean, they've said here it's true for all positive integers, but I don't even think, is that what they asked for? No, they didn't even ask for that. So you can use that language. It would definitely be accepted for this as well. Saturday, no, you don't get the mark. I think the last accuracy mark is only if the proof is correct, I think, but I'm not sure for that kind of stuff. Best to have a look in the mark scheme. Yeah, the specimen papers are quite unrealistic. I think the specimen papers are quite unrealistic for this stuff. So we will go on to the last part, which is some things with vectors. Now, the whole point of this question that I've selected is that it looks horrible. The whole point of this question is that it looks horrible. But can you try and remind me, what are the things that we can actually do with vectors in further maths? Like, what are the things we can actually do? Like, I'm, for example, going to say shortest distances. That's one of the things that we can do. What else can we do for this? You can draw pictures. Pictures aren't always that helpful, but they can be helpful. We can do angles between things, I'm going to say. What else can we do? Intersections, good. We can do reflections. Reflections is not a fun one. It came up in 2023. It's one of the longest ones that we've got. Obviously, cross products in further pure one, so I'm not going to be talking about anything to do with cross products. But basically, it's this. It's shortest distance, angles between things, or where do they intersect. That's it. So try and like drill these things down into, for a modelling question, into one of these 3 areas, and we'll decide which one it is, and then we just go and process what's going on with it. So imagine seeing this question. This isn't why the question is horrible. Look. There's then another part of this question. This literally took up an entire page that we've got here. And I must admit, this question from 2022 in Core Pure AS is crazy because of the fact that this line that we've got here is actually a curve. So we've actually got like a curve in this question. However, we are just going to keep our cool with this question and be like, okay, well, my teacher taught me properly. Bicen Maths, I've watched his videos. He's taught me this properly. Let's see what we can do for this. So, the surface of a horizontal tennis court is modelled as part of a horizontal plane with the origin on the ground at the centre of the court. Okay, so I am gonna draw a tennis court for this. The origin is in the middle of the court like this. The I and j are unit vectors directed across the width and length of the court. So I is going across like this, J is going across in this direction, which must mean that K is going to be where there's like the vertical bit. So K is going to be coming upwards. I'm going to add it on in just a second. We also know that there's like a net in the middle of a tennis court, right? So even though they haven't mentioned it yet, I'm going to do it just to kind of help us like visualize what's going on in this question, even though you don't need this to be successful in this question. So K is the thing that is going vertically upwards like this. Units are in meters. Great. After being hit, a tennis ball modelled as a particle moves along a path with this equation. Now, normally, we don't have things moving with this curve, but when something is moving as a tennis ball, it's obviously going to be moving in a curved path when you play tennis. It moves like this. Normally, when we do stuff in vectors, it is just going in a straight line. So this is kind of an annoying thing in this question. But they've written it in this IJK form. You know how I'm going to be writing this. You know I'm going to rewrite this as R equals minus 4.1 plus 9 lambda minus 2.3 lambda squared minus 10.25 plus 15 lambda 0.84 plus 0.8 lambda minus lambda squared for the K component that we've got like this. Now, this is if we want to go a little bit deeper, and I want to tell you this part. The I part and the J part have got... No, I'm not going to go into this, but these are kind of like linked to mechanics. The reason we've got these extra quadratic-y bits is because there's some extra acceleration that was going on. If we didn't have this, this just looks like the normal equation of a line that we've got there, and we can clearly tell what the equation of the line is. But we're just going to have to roll with the punches and say like, okay, this is what they've given us. Let's work with it. And they've said, assuming that the tennis ball continues on this path until it hits the ground, find the value of lambda at the point where it hits the ground. Where it hits the ground, what can you tell me about either I, J, or K, those directions? What can you tell me about when it's hit the ground? Very good. K is equal to 0. So this whole thing is just saying K equals 0. Just do that and find out what lambda is. So 0.84 plus 0.8 lambda minus lambda squared is equal to 0. Get it on the calculator. Minus 1, 0.8, 0.84. Lambda is 1.4, or lambda is minus 0.6. We reject this because the question says that lambda is greater than or equal to 0. Then it says, and this is something you do not need to know, but I'm going to ask you something in a second to see if anyone can spot something interesting. It says the direction in which the tennis ball is moving at a general point on its path is given by this vector equation that we've got here. And I just am interested, does anybody think they might know the connection between that part that I've highlighted in yellow and this part that I've highlighted here in green, what that might be? Wow, that's so quick. Well done, Jack, who I think was the first one, or there's someone with a symbol that I can't recognize of their name. Yeah, it's the derivative of this stuff that we've got here. And that's because when you have like a path of something, this is connecting back to mechanics. If this is its position vector, you can differentiate it and find its direction or its velocity vector. So for part B, I'm not going to call it velocity, but it is, they told us it was 9 minus 4.6 lambda, 15, and 0.8 minus 2 lambda. And they said write down the direction, so find out what this is when it's as it hits the ground. And as it hits the ground, that's when lambda is equal to 1.4. So it will be 9 minus 4.6 times 1.4, 15, and 0.8 minus 2 times by 1.4. So 9 minus 4.6 times 1.4, that is 2.56, 15, and 0.8 minus 2 times 1.4, and minus 2. Yes, we could write this as this. I don't think it's that important. They would probably give you that written in this kind of form as well, okay? Then it says, hence find the acute angle at which the tennis ball hits the ground, giving your answers in degrees to 1 decimal place. So it's one of these, right? It's one of the angles between things that we've got here. We're talking about the angle between the tennis ball, the way that its path hits the ground, and we're talking about the ground. So what two things are we finding the angle between here? We're finding the angle between a what and a what? Very good, Ramo plays. We are finding the angle between the line of the ball and the plane of the tennis court. So this is the angle between a line and a plane. And we know the formula for that because it's one I ask my students to memorize for this. the angle between a line and a plane is sine theta is equal to the direction of the line dotted by the normal of the plane divided by the magnitude of direction and the magnitude of the plane. Now our plane, we don't have what the plane is. Do we know what the normal is to this plane? What's the normal to the tennis court with that little diagram? It would have been nice if they gave us a diagram, I think. What is the normal direction for this? Yeah, just k, something k. I'm going to go with just 1k here. So I'm going to say that the normal is 0, 0, 1. It would work for anything as long as there's a 0 for the I, a 0 for the j, but something for the k. So I'm going to go for 0, 0, 1. And we've already worked out that this is the direction of the line, okay? They want the acute angle, which is why I've put these magnitude signs in. So this is 2.56, 15, and minus 2, dotted with 0, 0, 1. And that's all going to get divided by the magnitude of these both, which is going to be a 2.56 squared, a 15 squared, and 2 squared, and the square root of a 1. So the numerator becomes just a minus 2, but I've taken the magnitude of it. I've had to take the magnitude of it. Oh, hang on, I've lost the chat on my thing, so I'm just going to open up my computer because I've been talking for so long it closed. So the denominator, I'll just work out what the magnitude of this is. I just did the dot product up here. So 2.56 squared plus 15 squared plus 2 squared. I'll square root that answer. It's some horrible number, so I'm just going to write down a few of the decimal places and just finish this off on the calculator. So theta is the inverse sine of that. I need to make sure I'm in degrees mode, so switching back, 2 divided by that, inverse sine of that, and we get 7.5 degrees. I think they wanted it to 1 decimal place, which is what we've got for this part, for part C, but there's still more to do. Okay, we now have the net of the tennis court lies in the plane r dot j equals 0. In other words, r dot 0, 1, 0 equals 0. Find the position of the tennis ball at the point where it is in the same plane as the net. What do you think that's asking for out of those things like angles, intersections, shortest distances? What's it really asking for us to do if we're trying to find the position of the tennis ball at the point where it's in the same plane as the net? Very good. I think Kep was the first person with that. It's an intersection, right? So I'm trying to find out where the tennis ball intersects that. And the equation is something that I'm just going to copy and paste because I don't want to write this again. Okay, so let me just copy that. So that's what r is equal to. And I'm going to say that that thing dotted with the j is equal to 0. Oh, that's so easy because it's just going to be that thing multiplied by 1. So minus 10.25 plus 15 lambda is equal to 0. 15 lambda is 10.25, so lambda is 10.25 divided by 15, a horrible number, 41 over 60. And we want to find the position, which means I'm going to take this 41 over 60 and substitute it in here. And I'm sorry, but this is going to be incredibly boring for you to watch. But I'm going to do my minus 4.1 plus 9 of my answer minus 2.3 of my answer squared. And I'll do it to 3 significant figures, 0.976. That part I know is going to be 0 when I substitute it in, save a bit of time. And with my 41 over 60, I will do 0.84 plus 0.8 of that answer minus that answer squared. And you either can do it as a fraction or you can do it to 3 significant figures and we get 0.920. And this is to 3 significant figures. Yes, you could write this in IJK form. Like this, okay? So then it says, we found out where it was when it's going like over the net. The net is like, let's say the net is like here. We've now said when it goes through this plane where the net is, we know the exact position of the ball. The maximum height above the court of the top, the maximum height above the court of the top of the net is 0.9 meters. Modeling the top of the net as a horizontal straight line, state whether the tennis ball will pass over the net according to the model. So when it passes over the net, this is where it is. This, oh, if I put J, I'm sorry, I bet I'm going to look in the chat and people are like, why did you write J, sir? It's K. So we now are just going to look and say, how high up is it? Remember, the bottom value is the thing that tells you how high it is. So according to our model for part E of the question, the ball is 0.92 meters above the ground. And 0.92 is greater than 0.9, so it passes over the net. Someone asked, where did this part come from? It said that the net was r.j. r.j is just this component that we've got here. So according to the model, it will pass over the net. With reference to the model, decide whether the tennis ball will actually pass over the net, giving reason for your answer. So you can tell me what you think for this, but my view on this is that our model suggests it only goes over by like a couple of centimeters. So it is only 2 centimeters above the net, and we haven't considered the dimensions of the ball its radius is likely more than 2 centimeters, so it won't pass over. There's lots of things you could say for this question though. So like the diameter of it. You could say yes because of the sag in the middle as well. There's so many things that they want you to kind of think about for this. Now air resistance might have been taken into account, but I think it's more about the ball being modelled as a particle. This PDF I will just upload into the link that's in the description. I will kind of upload it into that folder that we've got here. So if you do want to have a look, these are some of the extra things that you could answer for this question, but we did get the 7.5 degrees and we did get the this part here. I wrote it like this part, and here's the 0.92 being greater than 0.9. So it's tomorrow. The session is tomorrow. I cannot believe that the session is tomorrow. I hope this has been useful to kind of go over some of these topics, and seeing this question, you're like, oh my God, this looks so stressful. Remind yourself, it's just certain basic things they can ask you about. Don't think you're gonna have to reinvent maths for this stuff. You can use your calculator to solve a quadratic when it doesn't say using algebra, or you can't use calculator technology for this kind of stuff that we've got, okay? So I am going to hang around for a bit longer to see if there's any questions of things that we want to answer about. If you like this style of session, the ones that I do on Zoom are so much nicer because I can interact with you more quickly. It's just like a nice atmosphere where there definitely wouldn't be 593 people, which is what we've currently got in here, which is insane. There won't be that many people that are in the session. So if you are interested in coming to the session that's on Wednesday morning, it is £15 and I will focus only on the topics for EdXL that have not yet come up, that are likely to come up in Core Pure 2. I have to do this as a session because I'm going to stay up late tomorrow night, like planning what this session will look like and try and make sure that it's like as spot on and kind of focused as possible for your revision, so that it's just a great way to spend a Wednesday. If you can't come to the session, which is at 11 AM, you can just purchase just the recording, and the recording is also £15. It'll be sent to you by about 3 PM, maybe even earlier than that, so that when you come home from school, it's like perfect revision to do. Not only will it just be the session, but there's extra questions that I will be selecting that you can then do after the session. And there'll be a video of me going through those questions as well. £15 for like 3 hours. It's going to be from 11 till 2, plus some stuff afterwards. It's going to be like 4 hours of content for £15, like such a focused way of doing it. If you want to register to do that for the £15 session, if you go to a link that's in the description, it's called the In-Between CP1 and CP2 session. It is worth saying it is just for EdXL. So that's something that I would just want to make sure it's just for EdXL for this kind of stuff that we've got. Right, is there anything else that we want to talk about? So I'm going to see if there's any other bits that we can kind of work through here. Let me just see. So the topics, no, it's completely random split of content between Core Pure 1 and Core Pure 2. Simple harmonic motion feels like something that I don't believe is going to be asked about because it's more in Further Mechanics 2. In Further Mechanics 2, it's its own dedicated topic. If it came up, it would they wouldn't ask you to do something with simple harmonic motion. They would just, like, it's the way the textbook was designed isn't a true reflection of what the specification is like, in my views. Simple harmonic motion, yes, there could be something that is represented by that, but it would be like handheld. They would kind of talk you through that kind of stuff, because simple harmonic motion is in Further Mechanics 2 rather than in Core Pure kind of stuff. Someone says, am I allowed to use a highlighter in your paper? Yes, I definitely would. Your exams officer might say, no, you can't use a highlighter. You can just highlight things that are not your writing. For example, I would not highlight my writing that I wanted an examiner to see, like that I've got here. I would not highlight this because it might block something out. But if I was looking at a question and I wanted to say, oh, make sure that you remember this thing, I could highlight that, because it doesn't matter if that thing gets blocked out in the in the recording, not in the recording, in the scan of it. It doesn't matter if that thing gets blocked out at all. What have we got here? I don't think reflections will come up because reflections came up in 2023. It feels kind of quick for them to kind of assess that again, but it could be the kind of stuff that comes up there. Recurrence relations proof are in the spec, but also that's in the further pure 2 spec as well. So for me, it would be quite surprising if that was also something that people asked about as well, because it's kind of tested elsewhere, but they have put it in the spec as well. It's not even, it's just kind of silly. I'd hope they wouldn't do a recurrence relation. You know what? Out of all the comments I've had, someone saying I'm handsome, it's just the best thing. Like, best teacher, best this, but like, no. Best handsome. Not best handsome, but handsome teacher, eh? What a nice compliment. So I will send these questions out later on as well that we've got here. What else have we got here? What kind of vectors questions do you think I'd like you to come up with? So my favourite thing that would come up, I would rather there be a vectors modelling question, because the modelling question looks so crazy and difficult, but actually the maths is quite calm. Whereas the other way around, if it's not, they kind of do things where there's like a vector and another vector, and then you're having to find a normal and things that are a bit more abstract. I think people find that kind of stuff quite hard. Okay, I'm going to stick around for a bit longer. If there's anything about like night before the exam, like what you should be doing tomorrow morning and stuff like that. Oh, someone said, am I using the new graphics calculator? No, I'm sticking with the CG50 because that's the one that you guys are using. So I'm trying to kind of like keep matched up with what you have. But when I'm starting next year, I use the CG100 because I think it's good. But I will be using it with like the new cohort of students because it's going to be the new calculator that they will be using basically. So it's more just getting used to them. But for now, because you guys are using the CG50, it makes sense for me to kind of use the same thing that I know you're using at the moment. So Amelia says, what should we do tomorrow morning? Something that just makes you feel calm and relaxed. If you have got to this stage with your revision and you know that you're doing as good as you can do, you're ready to go. There are a couple of things that I might do just before I was going in the exam hall. I did when I was doing my options modules last year, and there was a lot of content. I did have a couple of flashcards or like a piece of paper that had some key facts on that I always was forgetting because they hadn't gone deep enough into my memory. Reviewing one of those things just before the session is probably a really smart idea. If you review that, you then just have like the formula fresh in your mind. You can go in the exam hall and write it out, and it's just going to be done. So then you don't have to remember that particular formula that we've got. What else have we got here? Yeah, you do have to put the CG50 in exam mode. Someone at your school should be talking about that. What do you do the day before exam at night? Honestly, I would watch something nice on TV. I would make sure that I had something that I liked to eat that wasn't going to make my stomach feel upset or anything like that. And I would try and do things that make me feel relaxed, because we all know the maths we do is better when we're in a good frame of mind. Interestingly though, I do think nerves are a good thing. So like if it's tomorrow morning and you're feeling like, oh my God, I'm feeling kind of nervous. I said this to some other students, rather than saying like, oh, I feel really nervous, say to yourself, you know what, I'm actually feeling really excited about this. I'm feeling really excited that tomorrow is going to be an opportunity to show off everything that I've learned. And please remember, if you have a question that you think, oh my God, I'm absolutely like destroyed by this question, the first thing your friends are going to say to you when you come out of the exam hall, they are all going to say, that question was horrible. That question was so horrible. Of course, there's going to be one person who's like, oh, it was easy. It was so good. But I've heard those kids say that before, and often they haven't even got it right. So don't let other people stress you out. And if you don't like that exam chat afterwards where people are saying, did you get 12 for question 4? Did you get 8.6 for question 3? If you don't like that kind of chat, just take yourself away. Just go home. Just go outside with a friend who hasn't done further maths, because you don't need to hear that kind of stuff, okay? That's what I think anyway. And also don't try and put other people under pressure. It's such a difficult time of the year. If you can uplift your friends and make them feel like they're doing really well and they're smashing it as well, that's all we want at this stage. Remember, it's only tomorrow is one exam of 4. If it goes badly, you have got 3 exams to prove yourself, okay? I think it's going to be good. I think it's going to be good. Wait, do you actually have a custom Bicen Maths t-shirt? If this is true, you have to email me a picture of this. Please. If that is true, that would be hilarious. I don't believe you, but I love the idea if that is true. Bicen@bicenmaths.uk is my email address. Wow, the only further maths student in your school. That's so cool. So you've got gifts for me. This is so fun. What? No way. No one wants Bicen Maths merch. No one wants Bicen Maths merch. I did see a TikTok edit of me. It's me and Zishan Mats, who is also he's a great YouTuber. I didn't say also a great YouTuber, that's implying I think I'm a great YouTuber. And it's this hilarious TikTok of someone's done an edit of the videos with some weird music in the background. It was too funny. What are the exam timings? I think the exam timings are 1:30 to 3 o'clock. Oh, and I'll do the poll on the channel so you can vote and see how you thought that this went. I have a Bicen maths TikTok, but I don't really post on it anymore. I probably should get a bit more involved in tip top TikTok. I mean, any tips during the exam when we're stuck during a tough question? Just be like, you know what, this is really tough. I'm just going to go on to the next one, and don't make yourself spiral and think, oh my god, I can't do this one. I'm not going to be able to do the next one. I'm not going to be able to do this. I'm going to fail. I'm not going to go to uni. Just be like, you know what, that doesn't make me do better at maths. Just say to yourself, I'm just going to do the things that I can do, and just hope for the best. Okay. Never thought about anything with chewing gum. I wouldn't have chewing gum in an exam. When it loses the flavour, it's horrible. I wouldn't want that at all. This is so funny. I can't believe the idea of merch would be so ridiculous. Tips to avoid stupid mistakes. Yeah, just keeping yourself calm and knowing, like, at the beginning line of something, you know, when you're doing like a line of working and you know that that first line is like so crucial to get the rest of the question correct, just make sure that you've done that right. Or, you know, if it's this thing that you know you're often making mistakes with, definitely check it on your calculator as you go. If you do it at the beginning, it's not going to like give you a chance to kind of like bleed all of those mistakes through the rest of the question as well. And another tip for not making mistakes is when I did my work, I would like do a line, leave a line blank, do a line, leave a line blank. So if I needed to correct anything, I had like loads of space to be able to do that. But number one, don't really change anything tomorrow morning or tomorrow afternoon than what you've done previously. It has to be stuff that you're used to doing. You don't want to do like something for the first time in the exam hall. That would be stressful. If anyone, any tips on checking questions at the end? Yeah, when I checked questions, if I had spare time, I would do it in pencil on like the neighboring page, and I wouldn't check the answer. I would like literally redo the question, and then I would cross through it when I got the same answer. And if I hadn't got the same answer, I would play spot the difference and figure out which of these questions was more important, which question was correct and which question was like incorrect for this kind of stuff. To Jamie, should we flick through the paper beforehand or just start? Totally up to you. I wouldn't mess around with what you do typically. Like, I wouldn't change everything tomorrow, but I love looking through the paper at the beginning because it kind of gives me a sense of where it's going. And if I can see that questions 7, 8, 9 are absolutely weird looking, then what I do with that kind of weird looking questions is I'll have a quick look at them and think, they look a bit stressful, but I'll kind of process them in the back of my mind. And the other thing I do, if I know there's some weird ones at the end, is I go faster for the ones at the beginning to almost buy myself some time. Because the trouble can be is when you open the question, the paper, you're actually, all those nerves that you had suddenly are like kind of going, and you think, oh, I'm just doing like a roots of polynomial question on question 1. And you forget that you do need to have that kind of like pace throughout the exam. So take some of those nerves, reduce them a bit when you get when you open the paper, but let those nerves kind of like really like push you on from this. Oh, I've got a nice couple of little super chats. That's so nice. Thank you to, I think it's Heat. Thank you, Heat. And I personally like doing the paper in order, but whatever you do, Charlotte, just stick with the way that you have always done it. Don't mix it up tomorrow, because if it goes wrong, you will then be like, why did I change that for the time I was doing the exam? Why would I do that? The Discord server, I think possibly one of my amazing moderators that we've got in here. I've got Ash, Awan, and Ali, who are top legends for my members Discord server. There's a public Discord server. Maybe one of you guys wouldn't mind sharing a link if people want to kind of join the public Discord server that we've got. Oh yeah, I like what you just, thank you so much, Ali. Incredible Q Dog says, there's a tip I heard. Is it useful to read the question backwards so you know what you're solving first? Yes, that is quite nice. I wouldn't shift that if you haven't done that before, but you probably noticed if you've ever been in any of my Aiming for a Star sessions, whether you've been in like any of my live streams, what I tend to do is I start reading the question and I immediately start doing maths that I know is a part of what they're asking about. If they mention, oh, the plane intersects the line intersects the plane at point B, I'm like, okay, I'll figure out what B is before I've even read what the rest of the question is, because you know you're going to use it and then you've got like the information there. It feels a bit like less information overload with that kind of stuff. Yeah, good stuff. Good stuff. The members Discord is for people. I do like a once per week. We have like a drop-in session where we go over questions, and yeah, it's just fun. It's a nice little Discord. There's probably about like 15 of us, 20 of us, maybe a bit more. I'm not sure. Depends. I'm not sure on that, Kep, about the algebra versus matrices kind of stuff. I think it should still be okay. No, I think algebra, they probably wouldn't want matrices for that. What do I predict for tomorrow's exam? Now, these predictions are absolutely random predictions, okay? But I think that there's going to be second order differential equations tomorrow. I have no reason to believe this other than just like predictions. I think there's going to be a modelling with vectors tomorrow. And I think that if there is a proof by induction question, I don't think there's been divisibility for a while. I think that it could be divisibility proof by induction. I would like it if polar was tomorrow, because we've just done some polar stuff. So what have I said? Second order differential equations, maybe even coupled. This is not, don't base anything off this. I don't know what I'm talking about. No one knows until you open that paper. But we will know about what's coming up in paper 2, because they don't repeat big topics twice. So that's why I'll be up late tomorrow night planning that session, and I can see already a huge bunch of people have got tickets for that in-between session. So if anybody wants to come for that in-between session, or you want some extra stuff on Core Pure for tonight, you can get the recordings of some of the previous sessions that I've run on Core Pure 1 and Core Pure 2. It's going to be a late night though if you do that. So right, I think we should probably wrap it up here because we've been on nearly for an hour and a half. This has been insane. I cannot believe there has been over 500 people watching this live stream. This is madness to me. Like there are people that I like on YouTube and like Instagram and things like that, and I go on their lives sometimes and they're like famous people and they don't have 500 people in their lives. They have like way less. So the fact that I have currently 518 viewers is completely mind-blowing. I absolutely love it. And obviously I will be doing a live stream before the Pure paper, not Core Pure, but for the Pure paper. I'm not going to do one for the Core Pure paper because instead I'm doing this in between session. I know I've mentioned it a million times, but it's because I want people to come to it if they want to come to it. If you go to the description in the video description, go to the link in the video description, there's all the information there about this extra session that I'll be running in between Core Pure 1 and Core Pure 2. I can't wait to plan that. It's going to be such an exciting night tomorrow. Hearing what's on the paper, planning the session, meeting with you guys there. It's going to be really, really fun. Hey, we've got Karan here as well. I'm going to be signing calculators. I actually did go to a school. I went to a school near where I grew up because my friend's mother was the head teacher there. And I went and did a talk for the students. I did a talk about like my life and how I got to where I am. And then I also ran a session with the math students about like exam techniques, similar stuff to what I've been probably saying in some of these sessions. And at the end, there was like a queue of like 20 boys because it was a boys' school. And they all wanted me to sign their calculator. And I was like, guys, don't take the piss out of me like this. Don't be like trying to like take the mickey out of me asking for me to. And they were like, sir, we're completely serious. Like, we're completely serious. Please sign our calculator. So that was a really funny moment for me, but a very happy one as well because it was very nice. Okay. I kind of want to just hang out here for longer, but I actually think I probably need to close this live stream down because I think you probably need to either go and rest, or I think you need to go and do some revision, or I think you need to come to my in-between session that's linked in the description. Imagine if I did a meet and greet, that would be so funny. Okay, I think it's time to go, guys. So can we all please just say a massive good luck? I would love this chat to be filled with like tons of good luck messages because we've been the motivated ones who have run this session, come to this session, working through these questions. Good luck, everybody. I can't wait to hear how you think it goes tomorrow. I really hope that it's a good paper. I will be thinking of all of you tomorrow about 1:30, different times for different schools. I will be thinking all of you and wishing you all the best of luck, sending out a lot of positive vibes. And of course, look out for my reaction video tomorrow. There will be my reaction video coming out tomorrow. I can't wait. I can't wait. I hope it goes well, guys. I'm sure it will do. You guys are going to smash it. Okay. I don't want to go. This has been so fun. Go and rest. I'm going to go and have some nice dinner. I'm going to relax a bit. I might see if I can go through some comments because I need to get caught up on some comments. Obviously, was watching the Eurovision Song Contest at the weekend. So I took a little bit of time off to make sure that I could dedicate some time to one of my favourite things, the Eurovision Song Contest, which was good fun. I can't imagine any 18-year-olds are watching the Eurovision Song Contest. Are you? That is one thing I'd like to know before we go. It's big for my age bracket. When you get mid-30s, or should I say late 30s, it gets like that. What's my favourite thing about Manchester? The people in Manchester are so nice. I love the people in Manchester. They're so friendly. I loved the Sweden song too. It was so good. The winning entry was so stunning. I loved Austria's entry. It was incredible. No, I don't have a wife. I have a husband. So I probably forced him to watch it. No, actually, that's not true. He loves it too. He loves it too. Loves it too. It has been kind of problematic lately, but there's a lot of joy that comes from Eurovision. And there's a lot of joy that comes from it. Do I sing? I actually love doing a bit of karaoke. I absolutely love doing a bit of karaoke, yes. I'll let you guess what my my karaoke songs are. My karaoke songs, you'll never guess my karaoke songs. Ever, ever, ever. Right, it's been a full hour and a half now. I have to go. Wishing you the best of luck, guys. My husband is a therapist. He's a therapist. Offers therapy to people, like counselling and stuff. Yeah, I don't mind if people know I'm gay. It doesn't matter to me. It's important. The karaoke. Okay, I'll start singing a song right now, okay? I'll start singing a song in 3, 2, 1...